right. Good morning, good afternoon, good evening, folks. Thanks again for joining us for another stream of the Machine Learning Community Stand Up. With me today is my co host, Jake. Uh, and Bree, she is here. She's just behind the scenes. Bree, do you want to say hi?
Hi everyone. I'll be behind the scenes today playing producer. So
Yes. Yeah. So she is here. So if you have any questions for Bree, she will be here and she'll be able to see your questions. She just unfortunately isn't able to actually join us on the screen. But more importantly, we have our guest here, Jessie, who's going to be talking to us a little bit about model explainability. Jessie, do you want to give a quick introduction?
Sure. My name is Jessie. I'm a summer intern and I'm working with Bree on ML.NET stuff.
Awesome. All right. Yeah. Looking forward to all the stuff that you've been working on over this past summer. And I think that, folks are going to find this topic interesting. So if you don't know anything about model explainability, you're going to learn a little bit about that. And for those folks who are already doing that, you're going to learn what sort of what the team has been up to and what Jessie has been working on. But before we get into that, let's get into some community links. So let me switch over. Make sure I got this right. There we go. Awesome. So to start off, basically you can access all of the community links and all the things that we're going to be talking about at that link right there at the URL list, MLNet Standup 2021-0707. And to kick this off, let's start with this learning resource here from it's called ML for Beginners, and this repository, what it contains is essentially 24 lessons that you can basically complete over the process of 12 weeks, or again, because the resources are available to you, it can be completely self-paced, and however you want to go through this course. And what this is going to do is it was put together by some of the folks over at the Cloud Advocate team here at Microsoft, and it will take you through some of the fundamentals of learning machine learning. Now, one caveat, so typically we talk about .NET stuff here on this show, but in this case, a lot of the exercises are Python based. That being said, though, it is a really great introduction into, number one, what are the fundamentals of machine learning, and also how you can go about building machine learning applications and the general concepts that are associated with that. So make sure to give it a look, and that's over at the Microsoft/ML-for Beginners repository. We also have this other resource here from BushDev. And in this case, they're talking about k-means clustering in C#. So if you're not familiar, k-means is this technique, unsupervised technique for building machine learning applications. Common use case for this might be, let's say that you're trying to tease out some information and extract some information about perhaps a user data set, and you'd like to understand, are there similarities among my customers? Cases like that would really benefit from using something like k-means clustering. And in this example, the folks over at BushDev kind of take you through an example of how you can use clustering and using ML.NET and the whole process of that. We have this other presentation on YouTube. I believe this was for a conference, for the .vvm conference, and in this case, Daniel Gomez Jaramillo basically did an entire talk on how you can use ML.NET to build applications. I believe the use case here was sentiment analysis and image classification. And once you've trained your models using ML.NET for whatever problem it is that you're trying to solve, how you can then bring those models into your web applications, right? So think your Razor applications, Blazor, whatever it may be, you can embed these models inside of those .NET applications. So make sure to give that a look. It's a really great presentation. In terms of what people are building with ML.NET, in this case, it seems like Jaden Patel over here has this website called Play Sudoku. And essentially, my understanding of this is this is a web application that lets you essentially play Sudoku, right? So this game. And the way that ML.NET and machine learning and ML.NET specifically is incorporated or integrated into this game is trying to determine what the mental age is of somebody who is playing the game. So essentially, the implementation process is described here, what types of scenario was used, and how the model was trained. And additional resources in case you want to learn more. You can basically take a look at those. So make sure to give this a look. Looks like pretty interesting. I myself stay away from Sudoku mainly because I'm not very good at it. But definitely for the folks who are interested and who actually play this, it's a really great resource, and it's really neat to see how ML.NET or how you can use machine learning, right, to sort of enhance your application. This other one is another interesting sort of example of what people are building with ML.net. In this particular case, the author of this blog post essentially is using machine learning overall to solve a semantic search problem. So essentially, what the author here is trying to do is they're trying to take some sort of query, right? Say, for example, if you were entering into search, right, into Google or whatever you're Bing, whatever search engine you want to choose, and matching that with a series of texts and trying to understand, whether there are similarities or how that query relates to the text that's being sort of surfaced, right? Now, in this particular case, the author uses a wide array of technologies, right, to get this working. Now, ultimately, the application is going to run inside of .NET, and in order to do that, the author uses ML.NET. But some of the technologies that are used to help eventually get this application into a .NET environment are first and foremost Onyx to achieve that interoperability and get a Dilbert model, which I believe was trained, if I remember correctly. Uh, it's using the Transformers sort of library, which is very popular from Hugging Face. And it's a very popular library for working with natural language stock type models as well as a few other models, but primarily it concerns itself with natural language processing tasks. In this case, the author is using Dilbert to basically solve the task of semantic search. They then convert that into Onyx format, which is an interoperability format for machine learning models, right? Using Netron to inspect the model, they get the inputs and outputs of the model, and then once they have that, they use the apply Onyx transform that's part of ML.NET to basically use the model to make predictions or to get the outputs from the model, right? Something interesting though is there are some transformations that are done on the data itself. And in order to do that, the author actually leverages Torch Sharp, which is another library of Torch bindings for .NET, and that's essentially how they manipulate the embeddings and produce mass for the text inputs, right? And yeah, so basically they use a lot of these technologies and a lot of these libraries that are out there to essentially solve this problem. And again, ML.NET is part of that, where it makes it really easy to basically deploy this model or serve this model in a .NET application. So yeah, definitely give it a look. Let's see what else is happening if this loads. Our friend Arfat here built another solution which actually uses a lot of different technologies as well. It appears that this is a UWP application, so it's a desktop application that leverages WinML and ML.NET to essentially train. It looks like it's an object detection type of model to recognize .NET related technology. So in that case, if I move back here, you're going to see that it's identifying that, hey, this is a .NET sort of logo, and in this case, it's an Azure Functions logo, right? So that's leveraging a lot of technologies, but again, at the end of the day, it's within a .NET environment. If you weren't here last time and you missed some of the updates, you can definitely check out the previous community stand-up where we talked a little bit about this blog post that we wrote on the latest updates for June 2021. Or if you are more visual and or you prefer consuming it in other ways, John Wood here has been kind enough to create a video where he basically goes over and details some of the latest happenings within ML.NET. So make sure to give that a look. For you F# enthusiasts out there who would like to attend this conference, free conference, by the way, in July at the end of the month, there's going to be this conference. So there's been similar ones that have been hosted for, I think there's been some for Xamarin, there's been some for desktop, I believe for web services, all types of technologies that are related to the .NET ecosystem have been presented at these sort of focus conferences. And in this case, at the end of the month, on July 29th, it's going to be the turn for F# to sort of shine here. And one of the things that this conference will have somewhat of a focus on is how you can use F sharp not only to build web applications, which is actually a really great way of using F sharp, but also how you can use it for machine learning and data science type problems, right? And F sharp really lends itself quite nicely to solve those types of problems. Um, Last but not least, Jessie here wrote this post not too long ago, essentially, sort of encouraging or asking the community if you're interested in model explainability, which we'll talk a little bit more about. We'll also, I believe, Jessie will talk about the findings or preliminary findings from some of the responses in the survey. Um, Feel free to give your feedback and essentially just let us know, are you using model explainability, and how are you using it, or are you thinking about it? Whatever feedback you have, we would greatly appreciate it. And you can do so by going on and taking the survey here. So that was a bit of a long one there. But with that, I guess PowerShell decided to run itself. Let's switch over to Jessie here, and let's hear about model explainability.
All right, yeah, sounds good. So the focus of my summer project has been on model explainability and fairness and how we can further those stories to make sure that our developers are using ML responsibly. So to get into it, model explainability can be defined as can you say why the model made certain predictions based on the data you used to train it? And so this is more in human terms, and it's less about knowing all the technical know-how about how to build a model or the mathematical calculations that are happening behind the scenes, and more about at a higher level, can you tell what features were most important, or why did a certain prediction end up happening the way that it did? We should care about model explainability because it gives us all of these other things. It allows us to debug our models, it allows us to improve them, and then we can also do things like detecting fairness issues and building trust in our model's decisions. This is also really important when we're talking about regulatory compliance, and then in high-risk applications where we are dealing with data that has to do with making decisions about people, it's really important to make sure that we have some kind of understanding of what's happening behind the scenes. This ties in really closely with fairness, which is one of Microsoft's 6 guiding principles for responsible AI. We think of this as a major socio-technical challenge because it requires the intent of our developers to make sure that they're thinking about these things while they're building the models. And then the technical side, we need to have the tools and services available to make sure that people can build things responsibly. So we have these 3 goals, 3 major goals of fairness, and they're to have similar quality of service, to allow for allocating resources and opportunities in a way that minimizes disparities, and then to provide accurate representation. And you can see examples of this when you're talking about, for example, an object detection algorithm for detecting faces. If our data set doesn't include representative information, then we might have poor quality of service for different groups. Or if we're building an application that's trying to decide if someone's a good candidate for like a job interview, then we want to make sure that our data is not biased based off of older data, or that we're making sure that we have an equitable allocation of resources there as well. So currently in ML.NET, we offer a couple different options for explainability. We have model feature importance, which will be model specific. And then we have permutation feature importance and feature contribution calculation. So PFI is more global analysis. It helps you understand which features are going to be most important, or that your model thinks are most important in determining what the predictions are. And then the feature contribution calculator is more local analysis. So it takes you prediction by prediction. What were the positive contributing factors to your overall prediction, and what were the negative contributing factors? So to go into a little bit more detail about PFI, it actually measures the importance of your features by checking the error. So if you permute the feature and the error of your model's predictions increases, then that tells you that your feature was actually a lot more important to the model than if you change the values of a particular feature and the model error remains unchanged. To see a quick example of this, or some sample code, we use the calculate permutation feature importance function here. to understand what were the most important features in our taxi fare model. And here you can see that it was trained on features such as trip distance, rate code, trip time, payment type, or vendor ID. And the output on the right shows that trip distance, rate code, and trip time in seconds were the things that were most important to this particular model. And whereas distance and time seem to be really intuitive, to have a lot more to do with taxi fare than the rate code, that gives you an opportunity to improve your model and maybe omit rate code or take a look at what correlations rate code has with other things. And so you can build more understanding of your data set using explainability features like this. So this kind of brings us into our customer research goals within this area. I'm trying to learn more about the explainability offerings that people are looking for, what features or visualizations that you guys want to see in ML.NET. And then we also want to identify ways to improve the current explainability APIs to make sure that they're easier to use and that more people know about them. And then find out ways to improve fairness so that we can all be building more responsible models. As Louise was saying earlier, the survey is still live, so if you want to contribute, feel free. And I'll be sharing some key insights from the user studies that we've been conducting, as well as the survey results so far. So one of the things that we noticed in the user study was that among the group that is experimenting with ML.NET, maybe not using it in production yet or have a little bit less data science background, they don't necessarily have a lot of understanding about explainability and fairness in the context of machine learning, but they do understand that it's important. And they are looking for ways to integrate it into their systems. Some of the suggestions are around integrating it into the system where it's just part of the pipeline and it abstracts away any of the background or complexity in the calculations that you might need. And then for our more advanced users, they found ML.NET to be lacking in comparison to other frameworks, but they were interested in seeing ML.NET expand its offerings so that they don't have to move out of .NET to understand their models or to provide more insight. One of the other things that we noticed, and this was particularly about a task where we had users attempt to perform permutation feature importance on an AutoML scenario, none of the participants were able to complete the task, regardless of their data science experience or their ML.NET experience. And while this was in a shortened period of time, we do recognize that this is a major area of focus, and we're going to be putting some time and effort into making sure that this is as easy as possible going forward. And one of the other key insights was that visualizations are going to be a major factor in making sure that everybody, with no matter what their data science experience are, they can draw conclusions from visualizations pretty quickly, and that can improve explainability across the board. So going to the key insights for the survey, we found that accuracy was the most important model quality, with explainability and interpretability ranking around 5th, and fairness ranking at around 10th, which was actually the lowest place. But if you look at the results for our data scientists and those that are focusing on building really explainable and fair models, explainability actually ranked third, second or third. And so it's interesting to see the difference in background versus what the priorities are. The average rating for the importance of model explainability was around a 3.2 out of 5. And people cited reasons like reliability, confidence in their models, or making sure that their models are safe. So we do see that there is a lot of community sentiment that explainability and fairness as well are going to be important for the use cases, with the average rating for fairness being 2.75 out of 5, but only 9% of respondents already working on fairness. So we want to increase that number and make sure that we're building more responsible models. And then some more insights. Only around 50% had ever heard of or used the explainability features available in ML.NET, so the ones that I listed a couple slides ago. And the majority of customers hadn't heard of any of the other explainability features that we had listed in the survey that included features that are available in other machine learning platforms. So this goes to show that we need more documentation, samples, and tutorials, just as people called out, to make sure that everybody knows how to use them and to continue building up this amount of community knowledge so that we all can build more models with, more explainability already embedded. And finally, we had the top feature requests, which were decision tree visualizations and training pipeline visualizations. So that kind of leads us into what we're looking to do based off of this information. I already mentioned that we're really looking to improve the permutation feature importance experience. And we want to do that by improving the tutorials as well as the underlying API. And then we want to look into designing, prototyping, and testing explainability experiences that already integrate into the existing workflow. So ways that we can make explainability a lot more approachable and easy for our users. Finally, we want to continue to collect signals and make sure that we're thinking about ways to improve fairness overall, so we can continue to push forward with best practices around responsible machine learning as well as responsible AI. And that was everything that I had. So we can take some of the questions now.
I think I'm on mute. There we go. Sorry. Thanks, Jesse. I had like 3 windows open, so like with all the streams, it was like my network was lagging. Yeah, that was really great. It was a really good intro. Thanks for sharing all that, Jesse, because this topic is like, it's something that's very difficult to tackle, as you sort of mentioned in one of your slides, right? The tech problem may be easy, right? You kind of have an idea of what type of tech you can build to solve these types of problems, but the challenge is also one that is not just defined by technology. It's one that society also needs to sort of try to set some standards or guidelines as to how they would like to solve the problem of fairness and model explainability, and what does that mean. And I think that there's legislation, I believe, right, that in some countries where these are topics that are definitely being talked about. But maybe you correct me if I'm wrong, but I don't know if there's like this one sort of set of standards that people sort of could just check off a list and follow, right?
Yeah, that's what makes it really complex, is that we can't settle for having a list of things that we check off, because every problem and every application is going to affect people differently. So it is like we are, as Microsoft is looking towards kind of leading the way in responsible AI. We're starting with checklists, but I think things are going to go a lot further than that.
Yeah, absolutely. And I think I'm going to paste here a link. You mentioned a few resources, right, in your in your slides, but I think this is one of them, right? The responsible AI sort of page that Microsoft has, and I believe that some of the pillars that you talked about in terms of how Microsoft thinks about being responsible with AI should be there. Is that accurate?
Mm-hmm.
Awesome. So let's see. We have some questions. We actually had a lot of really good questions here. So Fuel Snabel asks, can you train a model to explain a model? Or how does, could you talk a little bit more about, what exactly is this thing? Like, is it a model that's trying to explain the model, or how does that work in terms of the techniques for explaining models?
So the techniques that we offer in ML.NET take a look at the predictions that your model makes, and then makes decisions about what are the features that your model is relying on the most to get the predictive outcomes that it's getting. But there are a lot of other different explainability techniques that are available. These two, I believe, are model agnostic in theory, so we might not be supporting them for every single scenario that ML.NET supports. But the idea of being able to permute the input data to see its effect on the model accuracy is definitely something that can be used with black box models, because you don't know exactly what's happening there. But there are other like highly mathematical techniques. Lime is another example. and that stands for local interpretable model agnostic explanations, and that uses it uses some linear algebra techniques to take a look at where the correlations are going to be affecting the predictions as well. I don't have a super deep understanding of these different techniques, but I've seen how they've been used in other frameworks, and would love to see kind of where we need to move that forward in ML.NET.
Awesome. Speaking of accuracy, and that's perfectly okay, right? Like I think this is something that's under very active research, but this is an interesting question from Fuels Nobel as well. Is a model, if a model is unfair or it has been found to be unfair, can you say that the model is accurate? What's that role between accuracy and fairness slash explainability?
Yeah, so this is actually a common trade-off that people are coming up against, that there is, you can't have 100% fairness and also have 100% accuracy, or at least that is like a concept that people are kind of, assuming within this area. And I think that there has been some research that is trying to go against that, that we can do both, but it might require more computing power, or it might require longer training times. But the one kind of more concrete example of a model that is very accurate but can still be unfair is if you have a biased data set. So if my data set doesn't include, it's not representative of the population that I'm trying to apply my data to, my algorithm, or the evaluation of my algorithm would tell me, oh, it's very, very accurate. Like I can predict with 99.9% accuracy that the rows in my data set have these certain predictions, or whatever testing data that I'm applying. It can have a very high accuracy for that. But then when I deploy it in the real world, where the combination of features might be very different than the ones that I had in my data set, or it was unbalanced, then it can actually be both unfair and inaccurate in the real world. So it does depend on, it depends deeply on every scenario whether or not you can achieve both fairness and accuracy, I think.
Right. And even in those cases where, let's say that maybe you can't achieve full parity, fairness, or you can't fully explain, are there ways of still putting out there, like say, here's this model, here's how we train it. Like, what are some ways that maybe, transparency and I don't know, maybe a note or something like that could help in still, maybe you're not achieving that full fairness, full accuracy, but at the very least you're being transparent about, how the model is built and some of the shortfalls. How can you go about being transparent that way?
Yeah, that's a great question. I think one of the good examples that we see of here is if you're building a model that's going to be deciding whether or not someone is eligible for a loan. So that's an example where you can't just say you're ineligible or you're eligible because my model said so. You have to provide backup data. You have to be able to tell your customer, in this case, the person that's coming to you to apply for the loan, why they were rejected or why they weren't. And because that gives them information about what they can do to make sure that they're eligible for the loan the next time that they apply. But it also makes you more trustworthy as the person who's using this model, as the lender in this particular example, that you actually have, like, there's reasoning behind your models. And in those cases where someone comes to you and you tell them, hey, this is why you were rejected for this loan, you can look and make sure that there's not any data in there that's rejecting them for a reason that you as an institution are trying to make sure that you don't want to be using for that kind of prediction. Like you want to make sure that it's not rejecting solely based off of gender or solely based off of race or ethnicity, like things like that, that you want to make sure that as a company, you're like legally obligated not to discriminate on those terms, but also like the ethical boundaries of what your company is standing for in that case.
Yeah, no, that makes sense. Yeah, thanks for that. So we're talking about techniques and talking about the models, but it seems like, what you really need, or something that would, get rid of a lot of the problems would be, what if your data set was just fair, right? Like Fuel Snabel asked here. Whoops, sorry. So Fuel Snabel asks, shouldn't the goal be to just produce fair data sets? How far can that take you, or is there more to it?
I believe that there are like a couple different stages where fairness like enters into the pipeline. So I've talked a lot about fair data sets, but there's also balance. Like there's also balance in your data sets to make sure that you have as much information about all the different features across the board, so that you don't have 1,000 examples of I'm trying to think of a good example, like 1,000 examples of trip time when you're trying to predict taxi fare, and only like 5 examples of of the trip distance. And trip distance might be as equally or as an important factor as trip time in predicting, but if you don't have as much information in that area, your model is not going to make the right predictions. And then going past even the data, just the pure data phase, when you get into the model, and like what I mentioned before, is there's the testing phase. And so you can have testing relies on your data sets, but also relies on the sourcing of where those testing that testing data set comes from, and then the combination of how many times has your data been trained on the initial data set versus how many times has it been trained on like a different ordering or a different combination of the original data. I'm trying to think of other examples. I know that there are other places that can introduce bias, especially within like the specific model that you choose, because there are models that are better for some applications, and there's some models that have some shortcomings. And I see Jake unmuted if you wanted to.
Oh, yeah. I just have one more thing on the data sets. It's very difficult to solve it at the data set part. So like for data sets, there might you might think that you could just make sure that there's an equal number of rows for on either side of a protected class or something like that. But in actuality, like information can be leaked, and how it like the problem itself might actually be biased, right? Like how, if you're looking at historical data and that data was created by people have biases, right? So that data came from a place where there were potentially unintentional biases in it, right? So the data is going to sort of be corrupted. It might be way like you're sort of too late. You'd have to go back in time to sort of create that data set in an unbiased way. So typically it's very hard to do. There are some things you can do, like Jessie said, trying to have a representative data set definitely helps, especially with things like image classification and object detection. But when things are strictly sort of numerical, it's hard to tell what is going to drive the end result of the model. That's where like some of the techniques that Jessie was talking about with like PFI and model explainability and learning how it's impacting it. But it's really hard to do it at the data set level, like knowing, like if you could look at a data set and know what predictions it was going to make, then you sort of wouldn't need machine learning, right? It's the fact that machine learning is finding those hard to find correlations to do its predictions. It makes it hard to sort of analyze your data set there.
Yeah, for sure. And definitely a problem, right, is that sometimes, one of the challenges that folks may have when starting out with data science and machine learning is, I don't have enough data. So now you're telling me, on top of the fact that I don't have enough data, now it's all of a sudden not representative enough, right? So, so you run into that challenge of, well, how can I get more data? How can I get more representative data? And oftentimes, like that's an easy, thing to say, like, oh, it's easy, right? Let's just get more data. Let's just get more representative data. But sometimes that can be costly and challenging, right? So it may not always be the easiest solution. While it can solve some of your problems, it's not the only solution. Mainly because, as you sort of mentioned as well, Jesse, sort of bias or fairness could be introduced at different stages of the pipeline, right? Which actually brings us over to this question here from Willem Maintz. And Willem asks, what options are there to monitor fairness in production and get an alert in case something happens?
I have kind of a comment on this. Do you have something, Jesse?
You can go first.
Okay. I think that monitoring it in production is kind of similar to asking the same question of how do you measure fairness. And so I don't know all the different techniques, but I have one, which is you can kind of think of, like, for categorical columns, you can see for each of the different values in that category, what is the false positive or false negative rate. And if those are outside of the normal, or whatever else happens in the rest of your model for the other categories, then that would be like an indicator that you have an unfair model around those categories. So yeah, I think it's similar to measuring. So it's not necessarily has to be done in production. It's probably something that you can do even after you train your model and you have your test data set, the same way that you would do cross-validation for accuracy or something like that. You can also do that sort of post-processing analysis based on a test data set to see how fair it is there. So you don't necessarily need to wait until production to do it.
Yeah, the only thing I would add to that is, detecting when something funny happens is also an application of anomaly detection. And so you might end up having one machine learning algorithm that's making predictions, and then another machine learning algorithm that's checking those predictions and making sure that nothing is, occurring that is out of the ordinary, or that your model is acting really differently in a specific case.
Yeah, that's actually really, really great that you bring that up, because you can have sort of like Fields-Nobel kind of alluded to earlier, right? Can you have a machine learning model to explain why my machine learning model is behaving, not behaving the way I expected to, or unfair? You could have models that take the output from one model and use that as the input for another model. Bringing it back just a little bit to sort of that question around fairness and accuracy, right? Fields-Nobel asks, or comments here, I find that defining fairness is quite difficult, and I have a gut feeling for it, but how would I be able to transfer gut feeling into code, right? And I guess something to clarify or to find a relationship, initially we talked about accuracy and fairness as sort of, being pitted against each other to a certain extent, where it's like, okay, well, am I trying to have an accurate model that is fair enough, or am I having one that's fair enough and accurate enough? But Jake would just mention some, false positive rates and other metrics that you can use for looking at fairness. So what role do metrics, the standard metrics that you typically would use to measure the accuracy of these models, play into also determining now how fair something is, right? And using like an actual measure of fairness as opposed to gut feeling.
So I think Jake touched on it a bit when you're talking about the false positive versus false negative rate, and if you're separating based off of a couple demographic groups, is the false positive rate and false negative rate equal across each of those groups, or are we not, favoring or disfavoring one specific group in general? I think it is. I think the question itself just lends to the idea that it's strongly a socio-technical challenge, and so you need to be looking at exactly what your application is doing, what the context is around it, and trying to make any kind of mitigations that you can think of, and then as you work forward, and as companies like Microsoft work forward, and figuring out what are some of the key fairness metrics that we can calculate, then I think that's just gonna evolve and be easier to do as we move on.
I just want to add to it too, like at least unless you have a problem that isn't unfair to begin with, like the data set isn't unfair to begin with, or the problem isn't sort of naturally unfair, then what was I trying to say? So that you are kind of always going to have to be like making a choice, right? We want our users to make the choice to be fair, especially when it matters, right? So like if you're choosing, Jessie touched on a bunch of these in her presentation, but like if you're choosing to allocate resources, we definitely want to make sure that you're choosing to prefer fairness over accuracy. Like there's going to be, because we can't get a perfect data, and because resource allocation in the past probably hasn't been fair, right? It's not going to be a fair problem, so you're going to have to make the choice, and we're hoping to provide you the tools to know how that choice, like how to make that choice and how to make a fair model. So I did see that somebody, let me see if I can find it. Oh, it may have been the one you were just asking about, like how do you bring fairness into code? And so we are investigating some techniques. There's, as part of, I don't know if we should maybe add some more links to our URL list, but there are things like FairLearn that have some like mitigation techniques, so that you can take your model, and even if it wasn't a perfectly balanced or fair data set and problem, the model you get at the end, you can sort of do some post-processing to actually change how the model works so that it is more fair and likely a little bit less accurate. It's kind of, basically, the model before overtrained on the data set that you were giving it, sort of trying to get the highest accuracy it can get out of it. And now you're saying, don't make those predictions anymore, like make more fair predictions. So from a pure accuracy standpoint, it's going to go down because it's going to be making different decisions. Like it already tried to optimize for the best accuracy and it led to an unfair model. So with these mitigation steps, you're going to see your accuracy come down, but you're going to see your fairness go up. And so we need to sort of help provide those tools and techniques in the ML.NET space.
Yeah, and currently, like Jessie, she showed a code sample and talked about it. So it's something that you can kind of do with code now. And Jake, kind of what you're alluding to is like, okay, well, how can we bring that over to the tooling? Now, how it sort of, or at least in its current, the way that ML.NET kind of works now is you have the low-level API, you have AutoML, and then you have the tooling such as Model Builder and the CLI, which help you do that. How would something like this, meaning like building tools and techniques for people to take advantage of building fairer models, how would that look like from an AutoML standpoint? Where for example, right now, Model Builder is now using NNI and FLAML frameworks to build this. Do some of those frameworks already come with some of those techniques, or how can they help leverage building fairer models? And you have that happy medium where you're not actually doing everything manually, but at the same time, you're having something do that as part of the pipeline for you.
So I don't really have a great answer for this yet. I'd say we're working with those teams to figure it out. There's some techniques out there today, like mitigation, that would happen sort of after the AutoML stage. Once you had your model, you can then sort of do a next step, which does mitigation. So it modifies how the model works to get more fair predictions. But I mean, this kind of is a research question. So we're working with MSR to figure out what are the best approaches, right? I mean, it is possible that during AutoML right now we optimize for one metric, which is like an accuracy metric. It is possible that while searching your search space, you could actually optimize towards multiple metrics instead of just one. So there's lots of avenues we can explore, and I think that NNI and our FLAML partners are definitely going to be going along with us on this journey to figure out what we can do here.
And folks watching, if you have any ideas of your own, there's that survey that you can provide your feedback in and let us know if there are some ways that you're currently working with that seem to work for you that you'd like to see in ML.NET. Yeah, let me see here. So in terms of tooling, so continuing along that, so you have AutoML, which can enable some of that. How do you see tooling playing a role, Jake, in building? Like, what sort of experience? Like, if given what sort of what you've learned over the past few months, that the teams have been working on this from a tooling standpoint, what do you see some of what sort of experience do you see ML.NET lighting up that would help make it easier for folks to adopt these practices into their workflows?
Well, I think it'll probably be an iterative process. Like, I think we're going to have to see what customers need. I think kind of even just based on some of the chat comments we've gotten in here, I think the first step will be sort of exposing our users to it in some way, right? Like teaching them about fairness and giving them graphs for explainability so that they can kind of visualize what fair, unfair might mean. But I think the sort of the dream would be if when you come into Model Builder, right now you choose your data set and there's like a advanced data options or something like that. I could imagine something similar to that flow where, like, in that advanced data options, instead of just choosing is this text or a column or text or numerical or label column, something like that, you could also choose if something should be a category and if that category should be protected. So you can imagine, like, there you're kind of telling us as the the person driving the product driving the AutoML that this is a column with categories that you want to be fair across. We would then take that into our AutoML and into our training process, right, to try to help you create a fair model, or at the very least give you the tools you need to analyze the model for fairness. So I want to try and get us there, right? Because I think right now, we sort of put all of that burden on the user without necessarily giving them the tools to visualize it or the tools to remedy it. And so I want to try and find ways to do that. But somehow they're going to have to tell us, which columns are the columns that have sensitive or data, and then we'll try to give them graphs to represent fairness, and we'll try to expose to them some of these mitigation techniques that we're working with MSR to integrate into our product.
Yeah, and Jesse alluded that too, right? Like, a lot of this, I know it's the sort of the answer or the response that folks love to hear, but it really does depend, right? And while the user does, how you approach fairness, it's going to depend on the problem and the features that you have. So there is going to be some user input, but it sounds like making that process easier, so the user isn't burdened with, like, okay, well, which technique am I going to use? That's something that could kind of be handled by AutoML or some other framework and tooling in the background. And then you're just providing the inputs of, like, hey, these are the things that are important to me. Great. Let's see.
One thing to add to this conversation, I don't know if we already mentioned
No. I'm just checking. You can do that while I'm looking for questions.
Okay, sounds good. One thing to add to it is you don't necessarily always want a fair model, right? Like, you could imagine a situation where you actually want to train your model to figure out, who needs the money most, right? In that case, you're actually trying to, allocate resources to people that haven't had, resources allocated to them in the past, right? So, having a biased model isn't necessarily a bad model. It kind of depends on its intent. So that's where, it's tough for us in our tooling situation to, like, we can't sort of enforce fairness because that might inadvertently be harming people. You have to know the intent and the use of the model and how it fits into the sort of bigger application to know if the model needs to be fair or, how it's going to, like, what problem it's solving, right?
Right. Yeah, that makes sense. So if you could, do you have your the slides still up? I wanted to talk a little bit more about, and while you're doing that, essentially talk a little bit more about. So you mentioned in terms of fairness, there's three sort of, I don't call them criteria, but things that are looked at, right? Like, or how do you determine fairness, or whether something can impact fairness? And if I remember correctly, one was allocation of resources, representation, and quality of service, I believe it was. Let me go ahead and bring this up. Yep, there we go. Quality of service, resource allocation, and representation. Could you talk a little bit more about those, Jesse, and maybe provide additional examples of what these mean, or maybe why these are things that basically are considered when looking at fairness?
Yeah, so one of the major things that's done when you're starting to build a model, you want to do what's called an impact assessment. And so you're going through your specific use case and trying to find all the places where things could go wrong. And these are kind of the main impacts that we found, or that one of the responsible AI working groups found when they were looking at these are from a presentation about the Azure cognitive services. And so they were trying to make sure to mitigate these three areas of problems. And so quality of service, you want to make sure that you're delivering effective service across different demographic groups. And the example that was given there was if we have a service that is like text to speech, or other way around, speech to text. We want to make sure that our product can accurately translate speech into text, no matter what kind of accent that you have, or what kind of dialect you might be speaking in. And so they want to make sure that if they're stating that this product is targeted to be used across a bunch of different contexts, we need to make sure that we are sourcing people from all of those contexts, sourcing data from all of those contexts to evaluate and test and ensure that our model is giving the best, equal service across all of those different places. The allocating resources or opportunities, the best example that I could think of, they didn't have one for the cognitive services that are available right now, but the example comes from if I have a model, and I mentioned this example before, but to go a little bit more in depth, if I have a model that is based off of older data or data about the existing demographic makeup of my company, and I want to be using previous data to understand who are good candidates to hire in the future. If my older data is biased against a certain group, or then it's going to make predictions that are going to continue to perpetuate that bias. And it's going to do that and continue to do that until you discover that it does have a bias there. So that would be a better example of allocating resources or opportunities. That one's specifically allocating opportunities. In terms of allocating resources, you can imagine a model that's trying to understand what places in a natural disaster need to have certain specific resources allocated to them. And then for providing accurate representation, I think the easiest examples for people to visualize are facial recognition software, or software that depends on like physical qualities of people. And if those aren't representative, that means that the model itself is not going to be able to perform identification of those people in a way that's that has the same quality as it's identifying others. And so you can see the language, the speech, or so the speech to text example also has to have proper representation to make sure that it can give that similar quality of service across groups. And representation in data is also important, even if you're not working with people, just for plain accuracy's sake. Like if we look at models that are trying to identify different types of flowers, and you give it 100 daisies and you only give it 5 roses, it's going to be a lot better at identifying that things are daisies, or it's going to be biased towards thinking that things are daisies because that's the pool that you use to test it on.
Yeah. Thanks for diving a little bit deeper. I mean, I think sometimes, when you look at these things, it's a little bit hard to think of real world examples, but once you start sort of to visualize and put it into perspective, right, it really helps. One of the things that sort of jumped out at me was that even though these are three separate bullet points, there's overlaps, right? Like, for example, I want to make sure in terms of quality of service, right? Like going back to your facial recognition and example, right? You want to make sure that it's fair across all demographic groups, for example, in facial recognition. That way the quality of the service that you're providing, whether that's, unlocking your, your cell phone or, whatever it is, right, is good for everybody, right? Not just for a certain group. So that's something that definitely jumps out at me, that although these are three separate bullet points, they actually overlap a lot.
Yeah, absolutely. So when people are going to build models and they're doing an impact assessment, they need to be conscious that what are the possible challenges that are there, and then which ones actually apply most to their context, I think.
Yeah, and the other thing that also, I guess, jumps out at me as well is, all this time we've been talking about, sort of fairness and explaining things and things like that. And you can certainly think about that from a, doing what's right type of approach, right? Like, hey, I want to feel good that, I'm providing my customers or my users with the best service, right? So from like you can come at it from like a feel good standpoint, right? But at the end of the day, especially if you look at quality of service type, if you look at it from a quality of service standpoint, it also, as a business, right, it's a bottom line. For example, if my product doesn't work the same for everybody, people who are underrepresented are not going to buy my product because it doesn't work for them. So this also has financial implications to it. It's not just like, you certainly can look at it from doing the right thing standpoint, but there's also, business and financial sort of costs to not, trying to build fair and explainable models. Let's see here. There's a comment here from Feels Novell. Maybe you'd like to sort of expand on this, Fuel. It says, it sounds like fairness is an a priori idea on how the model should behave, but then training on a data set, but is then training on a data set the best approach? Are there other techniques that could be better? Could you expand on that a little bit more, Feels Novell, in terms of
I can maybe touch on it a little bit.
Yeah.
So for some problems, it's tough. Like you're going to have to use a data set and train on it. For certain things, though, there are techniques that are used. So like with deep learning and image classification and object detection, the data sets that they're trained on are curated. So they're like very intentionally chosen, and at different layers, they're they're detecting some like universally applicable features on it. So like, edges and shapes and stuff like that. And so that's not trained like sort of specifically on your data set. But then when you get to like wanting to take that model and making it specific to what you're trying to predict, you'll do something called transfer learning, which you're then sort of converting it to your data set. So that process, going through, training on sort of a curated data set and then fine tuning it on your data set, is a technique that's used to sort of not necessarily make it more fair, but more representative. So there are techniques like that where I don't know if that necessarily touches on what you were saying, but that is like a way in image classification, object detection to help train a model that is more sort of universally applicable, and hopefully would lead to better sort of quality of service and representation by not being trained specifically on like your problem set.
Yeah, and we are running a long time, but I guess we'll end it on this, and we can literally keep going because you just brought up another really good point, Jake, which was talking about the types of models that you use, specifically neural networks, right? Those tend to be a little bit harder to decipher, and Feels Novell sort of talks about decision trees and using that they're not perfect, but they were easier to explain. And yes, there are some models or some algorithms that lend themselves better to explanation. So yes, choosing your model also makes an impact on how explainable these models are. But with that, I think we're at time. I just want to thank Jessie for coming on and having this really awesome discussion and, sharing some of the work that she's been doing and the findings. And yeah, hopefully folks learn. If you weren't familiar with model explainability before, you're a little bit more familiar with it. And, let us know, give us feedback through the survey, what your thoughts are on it. Jessie, do you have any sort of, last words, last minute thoughts?
Not really. I think we had a really great discussion, and I appreciate all the questions. Please give me more feedback so I can understand this area more. It's definitely open-ended and has a lot of questions that are still ongoing. So
Yeah, for sure. Awesome. Well, with that, thanks for joining, and we'll see you in 2 weeks. Take care. Bye.